All right. Oh, on my mic. All right, let's pick back up with our red pen and we will do some notes. So if we look at this entire sheet, we have back to the coronavirus. All right, we got the looking like an exponential model. Then we have our residual plot with a pattern. This looks exponential. Here's exponential form. And so how can we transform our data using this inverse? Basically, you just need to know that exponential and logarithms are inverses of each other. Exponential is when the variable is in the exponent. Log is when you have the variable inside the log. So they can switch around. Oh. Okay. And so what we're going to do now is look at this page. And so if you take the log of all the y values, that's transformed. So I'm just going to write transformed equation. And so we decided to transform by taking the log. You're not actually going to have to take the log of any other ones. What you have to be able to do is see one that's been done like this and then use it to predict. So you'll have an equation with the y inside the log and then have to solve for y to predict. And so that's when you have to hit second log to get it out. A second log. Or if we have ln, you hit second ln. If you have an exponent, you hit second to that. And then there's some other notes on the back for that. So let's look at this page. So far, we only have three types of functions that we do here. Linear, which is just y equals mx, well, y equals a plus bx. Power would be like y equals like x to the third, something like that, some sort of power, x to the b. And then exponential is y equals b to the x. So the x is up there. So I'll just put a b here. And then we have a linear scatter plot when you just have a linear one for linear. If you take log of x and log of y, you get one for the power. And then if you just take the log of the y's for exponential, then you get a linear one. So if you look back, we took the log of all the y's and it flattened it out. Now, it's not perfect, as you can see from this residual plot, that if you really zoomed in on this, there is still a curve right there. And so it's not perfect, but it does definitely flatten it out from this to that. Much better. To make predictions, you just plug in x and solve for y. You might need to undo a root or a log, and so I just have a couple examples of how to solve just in case that were to happen. So just hit second, whatever, to get it out. All right, now let's do this check your understanding together, and then you will be done with this unit, and we will do a review so that put it all together, and we'll go from there. So we'll look at this. Give the equation of the least squares. Everyone read this up there. It's always important. Okay, great. So what you can see is that it says weight versus length cubed. And so now we know our x is cubed. So to write the equation, we're going to write y hat equals a for 0.066 plus 0.014677 x cubed, where x is your length and your y hat is predicted weight. Okay, so suppose you catch one that's 36 centimeters long. Use the model to predict the fish's weight. And so we're going to say y hat equals 4.066 plus 0.014677 times 36 cubed. And so we just plug it right in. This one isn't too hard at all. So we have 4.066 plus 0.014677 times 36 cubed. And we get 688.855. Now let's make sure we have the units. It is in grams, so we're going to use grams. So I always want to have units. All right, and that is it. So what we'll do next is we'll give you guys a review sheet, and then you will be able to work through, check the answer key just like usual, and then we're going to move into our Stats Medic review course. So if you have questions about how to sign up for that, please let us know. We will put directions online for that in the calendar. Thank you so much. Let us know if you have questions.